Hello, everyone, and welcome to our webinar. Today, we're going to be talking about transforming your business with machine learning through Amazon Redshift ML. I'm Chris Selesky. I'm in charge of product marketing for Amazon Redshift, and I'm co-presenting with my colleague, Dilip Kikla, who's a global analytics sales specialist. Today, we're going to briefly cover Amazon Redshift, but we're mostly going to talk about machine learning and how it can transform your business. We'll get into some of the use cases and a demo that most of you will recognize as a common use case. Before we get into the actual content, I wanted to give a brief customer anecdote about a fascinating company called Magellan. They have a vision of bridging the gap between scientists and manufacturing in the area of pharmaceuticals and biotechnology. Their mission is to deliver the most effective and efficient pharmaceutical solutions to their customers. And they rely very heavily on machine learning, predictive analytics. It's central to their business because they needed to do things like forecast where drug costs are going and prices are going, to identify where the market is going and what drugs will be in demand. And also to forecast how patients will respond. They faced a very common problem that we see, which is their machine learning process was very iterative, it was time consuming, it was costly, and also prone to human error. Their data scientists had to do a lot of manual operations. They had to move the data, they had to transform it, they had to build custom integrations. They had to do things like grant permissions controls. And Magellan had a goal of improving their operational costs while not sacrificing the clinical accuracy, which is all important to their business. Redshift ML turned out to be the ideal solution to them because through our simplified model flow and automation, they were able to avoid all of those manual processes and actually achieve their goals by reducing operational costs by 20% without sacrificing any of the clinical accuracy. This example is very inspirational to me because, Magellan and companies like it are developing products that improve all of our lives and the lives of our families as well. Amazon Redshift is our cloud data warehouse, and it's foundational to machine learning for a couple of reasons. Number one, you can query data really fast, which is required for real-time predictive analytics. And number two, you avoid moving and transforming your data. Through automation, you avoid a lot of the manual tasks, such as those that impacted Magellan. Amazon Redshift integrates with other AWS services for an end-to-end machine learning solution. You'll learn more about that in Dilip's presentation as well as the demo. Amazon Redshift is the price performance leader, and in fact, it's up to 3x better than other cloud data warehouses in that all-important metric. And using our advanced query accelerator, you can accelerate your queries by up to 10x. And as your data sets grow from terabytes to petabytes, performance is consistent. Consistency is a tenet of performance to us. Amazon Redshift has many features that just work out of the box, including automation. So we have automated workload management and table optimization, so no tuning is needed to get the best performance. Amazon Redshift is very friendly to developers as well, because you can integrate semi-structured data such as web data and IoT data, and you can easily access the data through our data API. There are many personas across the organization that use AWS Analytics. There's the data scientists in the case of Magellan, but also developers, data analysts, BI analysts, business intelligence analysts. You use it for their reports to forecast things like profits, revenue, costs. There are a lot of use cases for machine learning in a data warehouse. We're going to cover one of them today in detail in the demo, which is very common, which is predicting customer churn, something every business deals with. Predicting sales cycles and whether a deal will close. Also, customer lifetime value predictions. This is something that leading companies increasingly are doing to forecast how their solutions are going to perform, and product recommendations based on a number of variables. There's market conditions, there's customer demand, there's the competitive environment, and so on. And of course, revenue and price predictions. And there will be new use cases as it becomes common in the industry. Some of the benefits of machine learning are most obviously in the case of Magellan to improve the business operations, to improve operational costs, also to transform the customer experience by having more personalization of web experiences, web ads, and so on. There's faster decision making, and also innovating on a product or a service. So the problem with a traditional machine learning workflow is that they're very complex and iterative. As we saw in the example, it takes a lot of time to prepare the models, to actually choose an algorithm and build the models. Then you have to train and tune them. There's management involved. You have to debug the models and manage different environments. And then there's the deployment phase where you have to deploy the models in production, validate all of your predictions, monitor them, and scale them to production environments. We sought simply to simplify this through a simplified model flow, and also to make it accessible to the various organizational personas, not just the data scientist, not just the IT administrator, but to the other personas as well. So some of the requirements are from these various users. That the data scientists obviously need to perform machine learning training and prediction within their data warehouses, and they need to use pre-trained models. The business intelligence professionals rely on it for their predictions, for their dashboards, for their business reports, and also the data analysts and developers who also need to train the models to make predictions. If they don't want to learn a lot of new processes, rely on external models. They want something that works out of the box, that's integrated with other services. And with that, I'll hand it over to my colleague, Dilip, who will do a little bit of a deep dive into Amazon Redshift ML.
Thank you, Chris. Our mission is to take our rich experience and expertise with machine learning and work with tens of thousands of customers to address these challenges. And do that by putting this powerful technology in the hands of every developer, data scientist, researcher, basically anyone who knows how to write SQL. We want to make it easy for all builders to easily build intelligent applications. In other words, we want to simplify machine learning. Let me introduce you to machine learning. That just simplifies ML using SQL statements. A user just interfaces with Amazon Redshift using their favorite tool. They would run the SQL command to create the model. Behind the scenes, Amazon Redshift ML securely exports the specified data from Amazon Redshift to Amazon S3 and calls SageMaker, autopilot, to automatically prepare the data, select the appropriate pre-built algorithms, and apply the algorithm for the training model. Amazon Redshift ML handles all the interactions between the Amazon Redshift, Amazon S3, and SageMaker, abstracting the steps involved in training and compilation. After the model is trained, It's deployed in Amazon Redshift. Amazon Redshift ML makes this model available as a SQL function in Amazon Redshift Data Warehouse. The user would then use this function in their SQL queries and perform predictions. Now that you know about how Amazon Redshift ML works, let me talk to you a little bit about its capabilities that help our customers in easily adopting this particular feature. The first and the foremost, it's simple to use. Users can create models, train models, make predictions using simple SQL queries. Users do not have to learn external tools or any of the machine learning languages. And we'll see that in a demo too. While simple to use, it does not compromise on flexibility. Advanced users who know about machine learning can extend that same SQL query to influence the training. They can specify a problem type, an algorithm such as XGBoost, specify tuning hyperparameters and preprocessors they prefer to be used. In either case, the execution of the steps is fully automatic. Without any user input, the pre-processing of the data, creation of the model, training, tuning the model, and deployment of the model are carried out automatically. The inference or prediction algorithms run inside Redshift. As a result, the algorithms leverage the power of Redshift's massively parallel processing architecture to run machine learning in the data warehouse in the performant manner. Now, throughout the model creation, training, and deployment processes, the customer data remains inside their own VPC. This enables customers to securely generate predictions using SQL without having to ship their data outside of their VPC. And this is one of the points that our customers were really concerned about. The other factor they were concerned about was cost, which is again a big factor for our customers. Now, breaking down our customers' machine learning costs, typically predictions or inferences drive up the cost in production environments. Now, this makes sense where customers train a model maybe once or twice a week. They could be running inferences on it thousands, if not millions of times in the same period. To minimize overall machine learning costs with Amazon Redshift, customers would not pay anything extra for predictions or inferences, as predictions happen locally in the data warehouse. Only the model training costs, which are about 10% of the overall machine learning costs, are additional. And there too, cost controls can be set through parameters like max cells and max runtimes during training. Moving ahead, now let's dive deep into the workings of the Redshift machine learning. There are three distinct ways users can leverage Redshift and SageMaker for machine learning, and I'll cover them in the next few slides. The first way, to create a machine learning model as a data analyst, you use a simple SQL create model statement. In that, you would specify the data in Amazon Redshift you want to use as the data input to train your model and the output you want to predict. As you can see from the example here, you need to specify the name of the model, customer churn in this case. You can specify the training data using a table name or a select query. In the query, a column that we are trying to predict, here it is marked as target, and the column is C active or active underscore cust. The final thing is specifying the name of the function through which we can then use this model to make predictions. When this SQL statement is run, Redshift ML behind the scenes will interact with SageMaker Autopilot to train your model. Once ready, it's deployed in Redshift. and the function will be available for predictions. In this example, to create the model that predicts customer churn, you can query columns in one or more tables in Amazon Redshift that include the customer profile information and historical account activity as the inputs, and the column showing whether the customer is active or inactive as the output, which is what we want to predict. Now, look at the second way the customers can interact with Redshift and SageMaker for machine learning. We also heard from our customer data scientists that they have already trained their machine learning models with XGBoost, MLP, or Autopilot, and do not want to retrain these models using Redshift create model statement. They are instead looking to leverage these models directly to run inference on the data in Redshift. The benefit with this approach is they get to use the powerful multiprocessing capability of Redshift while not paying extra for inference or predictions. They also do not need to export their data to S3 for inference. Now, we provide this capability to import models from SageMaker into Redshift. In the create model statement that you see on your slide, users specify the name of the SageMaker model and the function name as it's to be referred to in Redshift. Once this statement is complete and executed, users can now use the functions to run local predictions inside Redshift. The third way, this is also what customers requested us, is the capability to run machine learning models created in SageMaker to be run in SageMaker, but use Redshift data. This would allow customers to leverage algorithms that Redshift does not support as yet on the data which is residing in Redshift. We provide this capability as well by remotely invoking SageMaker endpoint from Redshift ML. So in this scenario that you're seeing on the slide, the training and the predictions both are performed in SageMaker. Let's look at a customer reference here with a job case. So job case, which you probably know is a job search website, it provides job recommendations to the users, the job seekers. With Redshift ML, they have reduced their time and cost for making job predictions while providing a better experience for their job seekers. They were earlier using an external machine learning platform with data pipelines built to export their data daily. That used to take them hours to get inferences or predictions. With Redshift ML, now they're getting their inferences in a few minutes without building any data pipelines. They're already seeing results with a 5 to 10% revenue improvement and also 5 to 10% improvements in member engagement rates. We already heard Chris talk about other customers who have benefited from Redshift ML across many other industries and use cases. With that, I'll hand it over to Phil for the demonstration of Redshift ML in identifying customer churn.
Hi, my name is Phil Bates, and my teammate and I, Bono Pitampali, are Redshift Analytics Specialist SAs. We're going to take a persona-based approach to show you how to solve a common business challenge. That challenge that we're going to be looking at today is customer churn. The challenge is we've been experiencing higher than normal rates of customer churn. Our current methods of doing analysis of churned customers to create customer retainment campaigns are not effective enough and not targeting the correct customers. Kim, the data scientist, has been tasked to create a machine learning model to predict customer churn. After meeting with Miguel, the data analyst, they come up with a plan to use Redshift ML, since the data needed is already available in their Redshift cluster. They will also enlist the help of Marie, the BI analyst, to help with creating the visualizations. Here are the steps that we will be going through today. First, we will create a model. We will then validate the model, run prediction queries, then analyze and visualize the results. Then we will also show how the data scientists can use SageMaker and Jupyter notebooks with XGBoost and be able to provide other detailed parameters in the create model statement. Now, let's take a look at the demo and see how Miguel creates his model and validates it and then does some predictions. First of all, let's take a quick look at the table that contains the data that Miguel will be using. He's got a customer activity table which contains many important attributes that should be able to help him create a good model to predict churn. Things such as account length, which is how many months a customer has been active, and the various plans that they have subscribed to, and what their recent charges have been. So now, let's take a look at our create model statement. As you can see, the create model statement in this example, it's very simple. In this one, we're doing auto ML. We will not provide any parameters such as the problem type or the objective or any hyperparameters or preprocessors. Miguel has chosen the attributes that he wants to use to try to predict the customer churn. So as you can see, we are going to use a state, area code, how many months the customer has been active, how many minutes they're currently been using, and what is their average daily spend and their average daily cases. All of these values here are the inputs. The last one you see here, churn, that is what we are predicting. You also see down in our target that we have that value referenced as well. In this case, we're looking for all the record dates which are less than 2020-09-01. This is going to be our training set that the model will be trained on. Later, when we are doing our predictions, we'll be filtering on a different date so that we can do predictions on a test data set. As you can see here, the other things that we provide is a function. We're going to call this predict customer churn, and then it's also important you need to provide an IAM role for a role which has permissions to execute and create a model. And you also provide an S3 bucket. This S3 bucket is where all the data is collected for the handshake between Redshift ML and Sagemaker. We have also an S3 garbage collect parameter. You see, we have set that off. The reason we have done that in this example is so that all the artifacts that are created during the create model statement are saved off, and the data scientists can analyze those for more usage later. So as you can see here, it's very simple. We are just wrapping our select statement inside the create model statement. Now, this model has already been ran, and we did it ahead of time because it does take about an hour to an hour and a half to run. But this is how you do it, and whenever you execute this create model statement, everything is done in the background. Redshift ML coordinates a handoff to Sagemaker Autopilot, and at that point Sagemaker Autopilot does everything behind the scenes, and this runs asynchronously. The create model statement itself will just take a few seconds to run, and then everything is running in Sagemaker. And you can do a show model command. It'll tell you the status of the model, and if it's not ready, it'll say that it's in training, or if it's had some other issue or an error, it will show that as well. So when the model shows that it's ready, you are then able to use that to do your predictions. So let's take a look at this show model command from this model that we previously created. As you can see, if you look at the model state, it shows that it's ready, and it shows that the validation in this case was a F1 binary because we did binary classification. There is our target column that we called churn. And if you look at the parameters, this is where you see the model type is auto. That's because we didn't specify any parameters. So Sagemaker Autopilot automatically detected that, determined that the model type was binary classification because we can only have one of two values, and it also has and creates an AutoML job name, and then there is our function name and parameters. This could be useful later. Say you have an analyst or someone that you want to say run the predict customer churn. You can point them to this show model command, and they can go find the function name and the parameters that they need to run. So now that we know that our model is ready, let's do some validation and see how accurate it looks. So as you see here, this first query up here, we are doing an accuracy rate calculation. We're doing that by comparing the actual value, the churn, with what our predict customer churn function will return from our test data set that we used. That was from the customer activity table where their record date was less than 2020-09-01. So and you see here that what we're comparing it, we're simply calling that predict customer churn function and passing in the parameters that we gave it in our create model statement. So let's see how accurate our model was against the training data set. As you can see, it's over 90%. It's 0.923%. So we have a pretty good accuracy rate there. So now that Miguel feels comfortable with the accuracy rate, he is ready to go and run a prediction. So what he's got now, he's going to check some things of interest that he thinks he wants to analyze, such as the account length, the total charge, etc. And he's calling predict customer churn function again, passing in those same parameters that we saw before. This time, he's changed the date. He's looking for everything that's greater than or equal to 2020-09-01. And he wants to see where the predicted active is false. In other words, these customers are predicted to churn. As you see, the results set, there are 380 customers that are predicted to be churned. One of the things, he can do some simple charts as well. As you see, we're using Redshift Query Editor version 2, and we have a few nice things that you can do in here. Miguel can do a simple chart. So he decides that maybe he'll look at a bar chart. You can change that here. And we'll look to see if we'll look at state for an example to see if anything unusual stands out. As you can see, some states appear to have more churn than others. You see Missouri here and Vermont over here. So we can also save that chart if we like and give it a name. Now that Miguel has done that and identified that there are 380 customers predicted to be churned, he wants to turn this over to Marie, who is the BI analyst, and let her do some further investigations. Marie will be using QuickSight, and we'll see that in a little bit. Before he gives that to her, he wants to make it easy for her, so he's created a view for her here, and he calls this predict customer churn view. So it's got the same query that we saw previously. Now he will just tell Marie to pull the data from this view, and we'll see what kind of insights that Marie has in just a moment. Now that Miguel has created the data set of customers likely to churn, Marie is going to go into QuickSight and show how easy it is to do some quick analysis and be able to share information with the customer service team as they develop programs to try to prevent these customers from churning. She's going to choose New Analysis and New Data Set. We'll go to Redshift Auto Discovered. She just has to give in a few details to get logged in. So validate the connection and choose Create Data Source. In this case, she's going to use Custom SQL. She decides to call this Churn Analysis. And she's going to select the data from the view that Miguel has created. She chooses Confirm Query. She's then going to choose to directly query the data and visualize it. first thing that Marie decides to look at is the state and get a count of customers predicted to churn by state. As you can see, there are some interesting things here. She can scroll down and easily identify which states have higher incidence of customers likely to churn. While that's interesting, Marie wants to also look at the total charge to see the impact of these customers. Again, she is easily able to identify by state which ones are most impacted in terms of the value of the customer's monthly spend. Now, she wants to look at it at the account ID level to see if anything stands out there. She quickly is able to tell that there are a few customers with much greater monthly spend that are predicted likely to churn. As you can see, these average monthly spend values are much higher than the next closest customers. As you can see, Marie has now been able to easily identify high impact customers, and they can now put together a program to reach out to these customers. This has illustrated how quick and easy it is to gain insights using Amazon QuickSight. Now we're going to demonstrate how a data scientist can use Sagemaker and notebook tools that they're familiar with to do machine learning, leveraging the Redshift Data API. So now, Kim is going to go into Amazon Sagemaker. She's going to look at the model that was trained earlier by Magellan. She can go to Hyperparameter Tuning Jobs and then select the name of the job that was ran. She can then click on the best training job, and she can see similar metrics that you might see from the show model command. She's most interested in looking at the best training job hyperparameters. Now that she's looked at that, she decides that she wants to go and create a model using some of her own parameters using XGBoost. She's going to use a Jupyter notebook. Up her Jupyter notebook that she's created for this. First, she's going to do some setup so that she can use the data API. Next step is data preparation. Since we're going to be using XGBoost, we need to have all the inputs converted to integer values. This step has already been done, but as you can see, she created a table called Customer Activity Transform, and she converted the state codes, the alphanumerics, to an ID. And she converted the churn values to be a 1 or a 0. True being 1, false being 0. And she's ran the data preparation step already. Now let's take it to create model statement that she ran. As you can see, the first part is the same as before, with the exception that we're using the new transform table with numeric values. And as you can see, she's set the auto off and the model type to XGBoost. She specified the objective as binary logistic. And she said for the hyperparameters to use all default except for the num round setting. And again, as we did before, you have to specify the bucket, and she's using S3 garbage collect off. Now, we're going to check the status of the model through the notebook here. So her show model command, as you can see, the model is ready. Now, she can run predictions inside the notebook. And as you can see, she came up with almost the same number of records as before the previous model. This one came up with 396 records or customers predicted to churn, and the other one was 380 that we did previously in the visual editor that we did. So you can see how easy it is to use the tools of your choice as a data scientist. You can use notebooks that you're familiar with, and you can put in the various parameters and objectives and model types as you create your models.
Thank you, Phil. Summarizing what we spoke about and saw today, with Redshift ML, customers enjoy a simplified way to do machine learning. It helps them in faster decision making, innovate on their next intelligent application, and transform their customers' experience while gaining a competitive edge. For more information about Redshift ML and to take it for a spin, go to aws.com/redshift and get started. Thanks, folks, for watching. Have a nice day.